Today we're looking at notes KK-1, rationals, day 1. So let's review your rational shapes. So remember, this looks like your rational parent function with asymptotes on both the x and y axis. Okay, and then points 1, 1 and negative 1, negative 1. This looks like your rational parent function reflected. You could either say it's been reflected over the x or the y-axis. Either way, it would create the same graph. Okay, not both axes, but one or the other. All right, that's this graph. You may or may not have seen a rational of this shape just yet, but if not, then you're in luck. We'll be looking at some that look like this today. All right, and then you will not see this. This is not a function, does not pass the vertical line test. Holes. Holes occur where factors cancel. You know I don't like that word, but it's kind of necessary in this case. Intercepts. To find an intercept, set the other letter equal to 0. You already knew that. To find the x-intercept, set y equal to 0. To find the y-intercept, set x equal to 0. Okay? State an intercept as a point. You knew that as well. Okay? The x-intercepts are also called zeros. You knew that. Or roots. Roots is what you'll see today. Solutions, too, is another one that you may or may not see. Okay? Vertical asymptotes, always in the form x equals some number. Okay, vertical asymptotes are found by setting the denominator equal to 0, then solving for that variable. Okay, horizontal asymptotes always in the form y equals some number. Okay, and to find HA, look at the degrees of f of x over g of x. In other words, the polynomial in the numerator and the polynomial in the denominator. So you need to look at the degrees of each individual polynomial and use this chart to decide. Remember that the degrees means the highest exponent on the variable. If there is no variable, then the degree is 0. Okay, so if the degree of the numerator is less than the degree of the denominator, then y equals 0 is your HA. If the degree of the numerator equals the degree of the denominator, then y equals the lead coefficients of f of x over g of x. And if the degree of the numerator is greater than the degree of the denominator, then there's no HA. More on this later. Stay tuned. To graph. Graph all the key features found, so any of these, all the key features, plug in a few extra points where needed. So that's what we're going to be doing now. On each problem, find A, roots, B, vertical asymptote, C, horizontal asymptote, D, y-intercept, and then E, graph. So this is an easy one to start off with because you should know this is the rational parent function shifted right 4, reflected over the x-axis as well as vertically stretched by 3. Okay, so we can use that knowledge to check the information we get and to check if the graph comes out like we think it should. So I've already set some of these things up just for time's sake. So roots, remember, means x-intercept. Okay, I want to know where the x-intercepts are. So to find x-intercepts, remember you set the other variable equal to 0. So in our case, that means set y equal to 0 because I want x-intercept. So y equals 0. I've already done that. 0 equals negative 3 over x minus 4. So I've plugged in 0 here. I've put 0 over 1, and I know I'm going to cross multiply. So 0 times the denominator, of course, because the 0 distributes to both terms, that's going to look like 0 equals, that will always, always, always be the case, because you'll always set y equal to 0, and so you'll always multiply 0 by the denominator, so essentially the denominator goes away. And then 1 times the numerator, which will always just be the numerator. So a couple things going on right here. So first of all, I want to point out this is not a true statement, which means there are no roots, no x-intercepts, none. Okay, so this right here has told us a lot just now. This has told us that every single time on these rational graphs, equations, that when we are finding x-intercepts, set the y equal to 0, always the denominator times 0 will be 0. And then 1, because you can put 1 in the denominator here, 1 times the numerator will equal the numerator. So in order to find your roots, essentially what you're going to do is set the numerator equal to 0. Okay, every single time if you want to find a root, you set the numerator equal to 0 and solve for the variable. Okay, that way you can skip the middleman, skip the steps, okay? To find the VA, like above, okay, set the denominator equal to 0, then solve. So denominator equals 0. So in our case, x minus 4 is in the denominator, equal to 0. Solve for x, you get x equals 4. Okay, so VA is x equals 4. So I'm going to go ahead and start graphing. I just like to graph while I'm finding the attributes. I don't like to wait to the end. I'm impatient, I guess you could say. Okay, so I'm just going to draw these right now. Maybe I'll need more ticks later, but this will be enough for now. All I want to draw right now is x equals 4. 1, 2, 3, 4 is my VA, my vertical asymptote. Okay, so there's my vertical asymptote. Don't have much other information other than there are no x-intercepts, which leads me to believe there's an asymptote there, but I'm getting there. Okay, so to find that HA, I assume there's one here on the x-axis, but let's use our knowledge of the degrees. So remember, I'm using this chart here. So I want to know, are the degrees of the numerator or the denominator, are they equal? Is one bigger than the other? Okay, remember I said earlier, if there's no variable, then the degree is 0. Here, my degree is 1. My highest exponent on a variable, the only variable I have is this one, is 1. So that means my numerator degrees are less than my denominator degrees, right? 0 is definitely less than 1. So numerator is less than denominator. So this situation, so y equals 0, just as we expected for many reasons. Number one, there's not any roots. So that leads me to believe there's an asymptote there. That's why there's not any roots. As well as, again, this should be the rational parent function only shifted right 4, so that horizontal asymptote should stay the same. The only thing that should change is the vertical asymptote, and it did. It shifted right 4. Okay, so then Y-intercept, x equals 0. Okay, so we have y equals -3, where I see x plug in 0 minus 4. So in other words, y equals -3 over -4. So in other words, y equals +3/4. So remember, you must write your intercepts, if you have any, as an ordered pair. So 0, 3/4. So now I'm going to plot my y-intercept here, 3/4. And I know that because I have that point there, this graph is going to hug the asymptotes here, hug the asymptote here. And I assume, because again, I've talked about the way this graph should look based on our knowledge from parent functions, I assume the other curve will look like this. But I can't just assume. I need that extra point. Okay, so I want to know what's happening to the right of my VA. So I'm going to plug in a point to the right of my VA. So my VA is at 4. I'm going to go ahead and plug in 5. I'm plug in 5 for x. Okay, so if I have 5 for x, that would be -3 over 5 minus 4. So in other words, -3 over 1. So in other words, -3. So I have the point 1, 2, 3, 4, 5. And 1, 2, 3, about there. Okay, so then this will also hug and hug. So this definitely verifies that this is my rational parent function shifted right 4, reflected over the x-axis, and vertically stretched by 3. I can see that here clearly. Here, I don't have that point. I could plug in 3 for x and find out for sure that the y value is 3, but this is enough. Okay, so now that was an easy starter. Okay, number 2, not so much. That does not look like our rational parent function at all, right? I mean, a little, but we can't tell the shifts based on what we have so far. Okay, so here's what we're going to do. If you have a polynomial of 3 terms, especially one that's x squared is your highest exponent, you are going to try to factor. So, we are going to do this. Y equals, okay, the numerator would factor to x plus 7, x plus 3. Hopefully you saw that pretty quickly. The denominator is going to factor to x plus 7, x plus 5. Okay, and look at this. So you can see here that x plus 7 and x plus 7 is going to, notice my fingers, cancel. Okay, so what does that create? Hopefully you remember, that creates a whole. So we're going to write our simplified version of this equation. We're going to write y equals x plus 3 over x plus 5. That's what's left. Y'all, this, I'm bubbling it because I just want you to understand this is what we're using to find all this information. We're not going back to this. We're done with that. Okay? So I'm going to kind of cross it out lightly. We're done with that. If you plugged it in the calculator, you wanted to see the graph, yes, you'd use this. But to find all this information, we're going to use this. Okay, so what has this just told us? Well, this just told us that we have a whole at, okay, x equals -7. All right, we have a whole at x equals -7 because the factor that canceled is x plus 7. And if you solve for x, you would get -7. So we have a whole at -7. I would like to find out the y value for where this whole is. So what I'm going to do is I'm going to get the y value. I'm going to say y equals -7 plus 3 over -7 plus 5. So my y value would be -4 over -2. And so that's going to be 2. So my whole is going to be at -7, 2. More on that when I start graphing, which I will start graphing soon. But I want to get a little bit more information. I know I'm going to need a lot of ticks, that's for sure. Okay. So roots. Numerator equal to 0. Remember that. Numerator equal to 0. So we're looking at this, our new equation. So x plus 3 equals 0. So in other words, x equals -3. Remember when I write my x-intercept, I need to write it as a coordinate, what it is, -3, 0. So I know I have an x-intercept at -1, 2, 3, 0. I know I have a whole at -3, -4, -5, -6, -7. 2, somewhere about here. Okay, that's not telling me a whole lot yet. VA, to find my VA, remember that's denominator equal to 0. Okay, so this is my denominator. Remember, I'm going back to this. I drew a light cross through that so you'd remember not to look at that. So x plus 5 equals 0. So x equals -5. So I can go ahead and plot that. That makes perfect sense. Okay, so -5, about right there. Okay, at HA, look at my degrees. So, my degrees are the same. Numerator equals denominator. Okay, this degree is 1, this degree is 1. So remember, if they match, then refer back to that first page. If they match, then you take the lead coefficients. So the lead coefficient here is 1 divided by the lead coefficient here is 1. So my HA is y equals 1. Okay, so now I can add that. Oh, this is starting to really look good. Okay, and last but not least, y-intercept. X equals 0, remember? Set the other variable equal to 0. So y equals 0 plus 3 is 3 over 0 plus 5 is 5. So 0, 3/5. Alright, so plot that point. It's going to be a little tricky. It's about as good as it gets. Out there. Okay, so I can tell for sure this graph is going to do this. And because of the hole over here, I can see this graph is going to do this. Again, if you wanted some extra points to make sure, you could plug in, say, -6. This is -7. You can plug in -6. You can plug in -8. But based on what I see here, the graph will certainly look like this. I think I drew my arrow on the intercept, and I definitely don't want to do that. There we go. Okay, last graph. All right, so we definitely need to factor the denominator, so we would have y equals 3 over, this will be x plus 3, x plus 3. No holes, no factors cancel. Okay, so no holes. We're going to use this. This is going to help us. Okay, so roots, numerator equal to 0. So in our case, 3 is in the numerator. 3 equals 0 is not a true statement, so none. No roots. VA, denominator, equal to 0. Okay, so denominator, you don't need to set x plus 3 twice equal to 0. Only once would be sufficient. You know you're going to get the same thing. Okay, so your VA is x equals -3. Okay, it's not like you can have two VAs right on top of each other, so you know it's just the one. And then HA, look at our degrees. Okay, our degrees, the numerator is less than the denominator, because the degree is 0 here, the degree was 2 here. Remember that, okay? So that means your HA is going to be at y equals 0 from the chart on the first page. And the y-intercept is where x equals 0. So you're going to have y equals 3 over 0 plus 3 times 0 plus 3. So 0 plus 3 is 3. Times 0 plus 3 is 3, so y equals 3 over 9. So in other words, 1/3. So 0, 1/3. Okay, let's see if this is enough information to give us a good graph. All right, so I have no roots. I have an HA on the x-axis, y equals 0. My VA, oops, that's definitely way too small. My VA is at x equals -3. I have a y-intercept at 1/3. Oops, I'm graphing like 2/3. Okay, so this point here shows me that this graph is going to do this. I'm definitely going to hug my asymptotes, can't pass them. So that's on that side. Okay, I don't know what's happening on the left side of my vertical asymptote. So I'm going to plug in one of these left values. So if this is -3, then I need to plug in, for my extra point, I need to plug in -4. So plug in -4 for x. That would be 3 over, that would be -1 times -1. Okay, so in other words, 3 over 1, so 3. So -4, 1, 2, 3. So that shows me that this graph, this curve, will be above my horizontal asymptote.